Hello learners, welcome back to the session. Just give me 1 second. Yes, let me just check if I'm online and we can begin. Okay, so in today's class what we are going to discuss is something that is going to be a very important topic, right? So we're going to see from your unit 1 electrostatics, okay, what are some important board exam questions you can actually expect, okay? So before we begin, my name is Mohana and I'm a physics educator here at Unacademy. I'll be taking class 11 and 12 physics. So I have my master's degree in physics. I'm also a plus verified educator. Now you can follow me through my Telegram channel and also, yes, this is my Telegram channel link, and again this link over here is the common ICSE and ISC board channel link as well. Okay, so you can follow both these channel links. Now before we begin, I'm really sorry, just give me 1 more second, guys. All right, so let's begin. All right, and just check if I'm online once more and we can begin. Okay, so your board exam timetables are out, right? So tomorrow at 3:30 p.m. on the Unacademy platform, we have a class that is going to basically target on how to score maximum mark. Okay, there we are going to do a board exam strategy class. So this is a completely free class. You can enroll for the session. Link will be down in the description box. Now, with respect to your class 12 board exam this year, right? If you see the weightage with electrostatics and current electricity combined together, it's around 14 marks. Okay, 2 units combined together is around 14 marks. But if you look at electrostatics alone, okay, you must go through the numericals. Okay, around with the overall paper, around 15 marks at least you can expect numericals. That is from the entire subject. Okay, so definitely you have to go through numericals. Okay, so you cannot skip them. Now with respect to electrostatic unit, what are some very important topics that you have to study and you can never skip? Okay, this would be, first of all, electrostatics forming the basics. You have to understand the concept, you have to understand, go through each and every concept. Okay, you cannot skip any concept, but one thing you can do is, okay, you can basically learn few concepts in depth, okay, or you cannot skip those topics at all. So one is basically understanding what is the Coulomb's force equation. Okay, make sure to learn the electrostatic force equation, right? Electrostatic force equation, when you're actually what is the electrostatic force equation, the Coulomb force equation, when you're actually learning, make sure to learn the vector form also. Okay, next important point, all right, this is in your 3-mark questions, mostly in the previous years, which was repeatedly asked, okay, was basically the question on dipoles. That is, what is the electric field because of a dipole, right? So if you take a dipole, we have a positive charge and a negative charge, right? Electric field lines always starts from the positive charge and terminate on the negative charge. Now on such a case, right, on a field line like this, right, because for this particular case over here, what we want to they always right, with respect to electric field lines over here, okay, for a dipole, what we want to understand is what would be the electric field lines on the axial line, that is the line passing through this particular charges together. Okay, so this would be some point over here will be your axial line. Okay, what would be the electric field on your axial line and the equatorial line? This mostly, in most of the previous year board exams, this question was definitely asked for 3 marks, and obviously this question doesn't come with an option, right? Few of the 3 marks you have either or option, right? But this doesn't, right? So mostly, even if it comes in the either or option, this question, electric field because of a dipole, was mostly asked repeatedly. Okay, highest possibility of you getting this question, I mean the possibility of you getting this question is very high, so do learn this particular question. Okay, now also what would be the field equation? Then other than this particular dipole, other than the question from with respect to the dipole, right, go through the numericals as well. Okay, so with respect to numericals, again there is a special class on the Unacademy platform that is going to focus only on the numerical part. Okay, now after this electric dipole, next thing you need to concentrate is definitely on Gauss's law. With respect to Gauss's theorem or Gauss's law, okay, do make sure to go through what will be the electric field line like with respect to a charge, and with respect to a line charge, with respect to a sheet, and as well as if you have a solid spherical, if you have a hollow spherical shell. Okay, how would the field lines be? With respect to line charges, it has a dependence on the distance, but if you take a sheet, for example, if you take a capacitance sheet, it doesn't depend on the distance, it doesn't depend on R value at all. Okay, so these classes, if you go through the website, if you go through the link, right, there would be a lot of classes that we have done. We have solved these concepts, right? How would the electric field line be with respect to a line charge applying Gauss's law? We have done it, so you can see that recording. Okay, now moving on with respect to capacitance part, right? Over here you can expect the parallel plate capacitor, okay, numerical based on it. Usually you can expect numericals with respect to capacitance when the capacitors are connected in parallel, when our capacitors are connected in parallel, or when they are connected in series. You can expect numericals in this case as well. Okay, now apart from this, right, electric potential is also very electric potential and potential difference, that is also very important. Please go through the topic also. Now what we are going to do in today's class is very simple. Okay, most repeated question, that is, what is the electric field line because of a dipole, right? Let's learn this question, let's by heart this. One reason why we are doing this is most expected question, and there is a very high possibility you can see this. Okay, you can get this question. So very simple, what is a dipole? Dipole is very simple. You take two charges, okay, let's say one is a positive charge and another is a negative charge. If they are separated by a distance, right, let's say the distance of separation between them is from the center of the charge to the center of the dipole. Let's say this distance is A. Let's say this distance is A. Okay, so the total distance between them will become 2A. Now what will be the charge, or what will happen to the field line for such a charge over here? The field line will start on the positive charge and terminate on the negative charge over here. Okay, so when you have a dipole, the field lines are no longer radial, right? They tend to bend. They start at the positive charge and they end on the negative charge. Now when you have two charges which are equal and but opposite polarity wise, one is a positive charge, another is a negative charge. So if this is minus 1 microcoulomb, this charge will be plus 1 microcoulomb. Okay, this basically tells you an electric dipole. So you can measure electric dipole moment is a term that just measures what is the strength of an electric dipole. That is given by a very, very simple quantity, right? It just tells, okay, what is the charge of what is the magnitude of one of these charges, okay, and what is the distance of separation between them. That gives you what is the electric dipole moment, and its direction is always from the negative to positive charge. Okay, these 2 points you need to know. Now coming back to one of the most repeated question that was asked, right? If you have a charge, right, what will be its dipole moment? Okay, what will be the field line along the axial line? Okay, somewhere around here you want to find what is the charge, and somewhere around the equatorial line also you want to find what is the field equation. How would the strength of the electric field differs? Okay, most repeated 3-mark question. Please go through it. All right. So with respect to this, very simple, on the axial line, extremely simple. Okay, so you take a point, you take two charges over here, right? One is a positive charge, another is a negative charge. Now let's say at a distance, at a particular distance, okay, let's say this distance is somewhere around R from the center of the charge, this distance we have taken, right? Let's say this distance is actually R. Okay, somewhere around this distance you're going to introduce a test charge. Test charges are always positive unless and until specified. Okay, so this distance, let's say this point is actually P. Okay, now the distance between these two charges is going to be 2A over here. Alright, now at this point P, what is the electric field, right? At this point P over here, what is the electric field line because of these two charges. Because of these two charges, what is the field line over here? Okay, very simple. Easily you can write, step by step you can write, and also you can do it very, very easily. Okay, what is the total field over here? Total field at the total field along the axial line, right? Axial line is the line passing through these two charges. Okay, the line parallel to these two charges. Okay, that is passing through these two charges over here. So that is the axial line. The axial line over here, the electric field at this point over here, if you introduce a test charge, it's going to be because of two charges. One because of this negative charge, another because of this positive charge, right? So if you see, this test charge over here will experience a force of attraction because of this negative charge, right? So it will experience a force of attraction because of this negative charge, and it will experience a force of repulsion because of this positive charge over here, right? Because of the positive charge, because of the negative charge, it will experience a force of attraction, and because of the negative charge or positive charge over here, the test charge being a positive charge, it will experience a force of repulsion. Now that force gives you the total force over here, right? So what would be the total force in this case over here? In this case, this will be, what is the electric field line because of the negative charge at this point, because of this negative charge over here? Electric field line is given by 1 by 4 pi epsilon naught, right? The charge over here, that is in this case the charge magnitude is q, divided by the distance of separation, the whole square, right? What is the distance over here? One is this distance to this distance is actually a. From here to here it is r, right? Because this is 2a, means this distance is going to be a, this distance is going to be a again, right? So again this distance is again a. So a plus r, right? So this will be r plus a the whole square. That's it. Very simple. Okay. Now with this, if you add, okay, one thing is, because this is a negative charge, you can take it as a minus sign. Okay. Now the next point we are seeing is what is happening with respect to the positive charge over here. With respect to the positive charge over here, right, this distance is again a, right? From here to this point over here, if you want to see at this point, because of this positive charge, what is the field line? This will be 1 by 4 pi epsilon naught q divided by, what is the distance between here? This distance is r, this distance is a, so it will be r, this whole distance, minus a, right? R minus a the whole square. So you just have to solve for this, that's it. Okay, you just have to solve for this equation. You will get 1 by 4 pi, right, epsilon naught q divided by r minus a the whole square minus, I am bringing the minus sign outside, 1 by 4 pi epsilon naught q divided by r plus a the whole square. You can take certain terms common here. 1 by 4 pi epsilon naught you can take commonly, sorry, q also you can take commonly outside. Okay, then all you will have is 1 by r minus a the whole square minus 1 by r plus a the whole square. In all of this, there is one more important point that we have to take into account, is the dipole moment. Okay, now because there is a dipole moment in this case, and because we are writing the vector equation, right, what we will do in this case is we will add the dipole moment unit vector also, that is basically p cap. Okay, so this is a unit vector, it is just giving the direction of the dipole moment, and this is basically p cap over here. That's it. All you have to do is just solve for this particular term over here, okay, and we will end up getting the dipole along the axial line, right? This particular dipole moment along the axial line, right? In this case, if you tend to solve over here, what we get is, I'm sorry, just a second guys. Right, what we get along the axial line, the dipole moment, when you try to solve for this, is nothing but we will have 1 by 4 pi epsilon naught, right? And we have q divided by 4 pi epsilon naught, and if you solve this term over here, okay, we will end up getting, okay, 4 into a into r divided by, over here we will get r square minus a square the whole square. That's it. Very simple term you will end up getting. Okay, I'm just going to doing a quick recap of this particular topic. Okay, in depth of how we can solve all the steps, I've done a previous video. Okay, do check that out. But I'm just telling you the most important question. I'm giving you a quick recap. Okay, so here if you see, dipole moment is given by 2 into a into Q. Right. So here you have 4 into A into Q over here. Right. So from here you can write 2 into A into Q, right, and you will have 2 into R, right. So divided by 4 pi epsilon naught, then you will have R square minus A square the whole square into P cap. So this quantity is nothing but dipole moment. So we can write this as 2 into, okay, R into P. Now we are going to take a very small assumption over here, okay, that is this distance R could be somewhere around, for example, 10 centimeters. This distance could be somewhere around 0.1, okay, 0.1 unit. Now what is 10 square over here? 100. What is 0.1 the whole square? 0.01, right? So A itself is small. When you do A square, it becomes still small. The value still reduces, right? So here what you can do is, because R A square is very much smaller than R square, we can neglect A square term over here. If you neglect the A square term over here, all you will end up getting, right? You will end up getting the equation for the axial line to be nothing but 1 by 4 pi epsilon naught 2 into P, right? A square goes R to the power 4 and R, that cancels, and you will end up getting R cube into P cap. Okay, this gives you the electric field line along the axial line. Okay, now if you solve for the same along the equatorial point, that is, okay, initially from here to here, let's say you went a distance of about 1 meter and you saw what is the, for example, okay, and let's say this R is equal to 1 meter, and you went and you saw what is the electric field line over here. Now, okay, from here if you go 1 meter perpendicular to this dipole field, from the center you are going 1 meter. This is nothing but your equatorial point of the dipole. Okay, so with respect to this, it is very simple, right? This total distance is 2a. So from here you are going a distance of r, that is about 1 meter, right? And you are going to see, right, let's say this distance is r over here. So this distance from here to the center point O, we can say this is a and this is a over here, and this distance being r. Okay, now if I introduce a test charge at this particular point over here, right, it would experience a force, right? It would experience a electrostatic force. Here, because of the positive charge, it would experience a force towards itself, right? Sorry, because this test charge is positive, it will experience a force away from itself, right? This would be because of the positive charge over here. Test charge you are introducing is always positive unless otherwise specified. This positive charge will repel this charge in this direction, and the negative charge will attract this charge along this direction over here. Right, so these are the two different, these are the forces that is exerted on this positive test charge over here. And what we notice over here is, now we have a vector, okay, and we have to resolve these vectors to get the final answer. Okay, now one thing we can notice over here is, this is a right angle triangle. Okay, this being a right angle triangle, this distance is r, this distance is a over here. Okay, so from here what you can get? This distance over here will be nothing but, this particular distance over here will be nothing but, okay, very simple. According to Pythagoras theorem, let's say this distance over here is x. What will be x? X will be root of r square plus a square, right? This is r square plus a square is going to be x. That is the distance value over here. Very simple calculation over here, right? So from this charge to the point P where you are introducing the test charge, the distance is r square root of r square plus a square. So this distance is also going to be root of r square plus a square, right? Very simple over here. These are the two distances that we are getting. Now what we are going to do, we have to resolve this component over here. Okay, so let's try to resolve this particular component. So one we have is a positive charge over here, right? We can resolve this into its two components, that is one along the one is the vertical component, another is basically its horizontal component over here, right? So another is going to be its horizontal component. Okay, so from here from here what we notice is then, okay, similarly there is another vector over here, right? So vertical component, okay, we have a vertical component and a horizontal component. Similarly over here also for the second vector we have a vertical component and the horizontal component. Look at the vertical component here, they are equal and opposite, so they tend to cancel out each other, but the horizontal component tend to add up. Okay, so from here again for this particular vector, this is basically E, this charge with the electric field because of the negative charge, right? What we see over here, this is again there is a vertical component and there is a horizontal and vertical component. These two components tend to cancel out each other, so what we have is the single horizontal component. Now this angle over here is theta, the angle it makes with this particular angle, okay, this component, what it makes with the resultant, this angle is theta, right? So this angle is again theta, right? So there is a straight line, okay, so there is this is basically a straight line, okay, sorry, this is a line, okay, this is a vector over here, and again here you see another vector. Now this line is a parallel line over here, and to this parallel line there is a line passing through these two lines. There is a parallel line here, there is a line over here, these two are parallel lines. To this there is a line passing over here, which means whatever is this angle over here, okay, the angle over here will also be the same theta. Okay, very simple. Okay, so again this is a straight line, this is a straight line over here. So with this parallel line, this angle is making an angle theta, okay, this vector is making an angle theta. So this is a straight line, okay, we have not drawn it perfectly straight, but this is a straight line, and again for whatever angle this theta is making with this parallel line, so because this is a parallel line to this one, this line will also make an angle theta over here. Okay, very simple. From here, if you want to resolve the components over here, very simple, okay, this component we have an angle theta over here, right? So this component will be nothing but E plus Q sine theta, right? This is going to be E minus Q sine theta, okay, but E, Q, positive and negative sign for cos theta tends to get added up. Okay, so when you're finding what is the field line for this particular charge over here, okay, what you're going to take is two different things, that is, one is electric field line along the equatorial. If you see, okay, it is only because of the positive component of the horizontal component of the plus Q of this E plus Q, and the vertical component, okay, and the horizontal component of E minus Q, right? The electric field, because of the electric field of attraction that test charge the test charge has because of the negative charge. Now this E plus Q and E minus Q are equal, magnitude wise they are equal, which means you can write this particular equation as E 2 times, okay, you can take any one charge, right, 2 times, okay, we can say this is nothing but we can take with respect to the negative charge only, okay. So we can take this with respect to the negative charge because both are equal, right? So we can take it with respect to the negative charge and we can say this is E minus Q into cos theta. E value is very simple. It will be nothing but minus 2 into 1 by 4 pi epsilon naught, okay, Q divided by, what is the distance of separation between them? Root of r square plus a square, the whole square. So square and square tends to get cancelled. So all you will get is r square plus a square. And we want to find cos theta. So if you see, right, we have a right angle triangle, right, and over here this distance is a, this distance is root r square plus a square, and this distance is basically, in this case this is basically r, right? So we want to find, this angle is theta, we want to find cos of theta. Cos of theta will be what? Very simple. What is adjacent side? That is a divided by hypotenuse. This is going to be root of r square plus a square, okay, into the dipole moment P. Okay, now all you have to do in this case over here is solve for this particular equation. We have 2 into Q into A. This ends up becoming P, right, divided by, we have 4 pi epsilon naught. And if you solve for this, right, you will get r square plus a square, the whole to the power of, okay, 3 by 2 into p cap. Again we use the same formula, that same logic, that a square is extremely smaller, right? A square is extremely smaller when compared to the distance r square. Okay, so we can neglect the term a. So if you neglect it, the equatorial field, along the equatorial field, what you find is minus 1 by 4 pi epsilon naught, okay, p divided by, here we get r cube. Okay, that's it, into p cap. This is going to be equatorial field lines along the equatorial plane. Okay, this is the field line you will end up getting. Now, from here, okay, one thing is, how did we end up finding the cos theta? Because this angle theta is equal to this angle. So here we have a right angle triangle, from here you can find. Now, very simple, from here what did we find? Axial point, whatever the magnetic field is on the axial point, it is going to be twice of that of the equatorial plane. So for example, if here the magnetic field line is 1 means, Newton per meter means, here it's going to be 2. Okay, along the axial line, the intensity of the magnetic field is more. So the electric field of a short dipole at a distance r from along the axis is twice the electric field at the same distance along the equatorial line. Okay, this is your electric field intensity along the end on and the broad phase on position, right? This is basically electric field along the axial line and the equatorial line. A very important question that was repeatedly asked. So do make sure to go through the videos in case if you want a detailed if you want to understand in detail how we solved all these steps. You can refer the previous class videos as well. And once again, tomorrow at 3:30 we are going to have we are going to do a session on how to score maximum mark in your board exams. This session is going to happen at 3:30. So this is a completely free session. We're going to discuss what are the important questions you can expect from different units, what are the weightage of each and every unit, okay, and any tips you want you can ask me during those class as well. So you can, the link is in the description box, go to the description box, it will take you to all the free classes available. So do enroll for the class tomorrow. Alright, I'll see you all in the next class then, and do like the video and share it among to your friends, and subscribe to the channel and click on the bell icon for notification.